Today's lesson is lesson 9-1, 9-2, day 1. And our objectives for today's lesson are to identify key features of quadratic functions, including the zeros, the axis of symmetry, the vertex, and the domain and range.
Alright, quadratic functions, we usually see quadratics because it's in the form of f of x equals ax squared plus bx plus c. A, b, and c are real numbers, and a is not allowed to be 0. Also, it's non-linear, meaning it doesn't make a line, it makes a U shape or a parabola. Some parabolas open upward, and some open downward. The value of a determines the direction that the parabola opens. When a is positive, in other words, this number in front of the x squared is positive, it opens upward, meaning that your arrows are going up. If the a is negative, in other words, the number in front of the x squared is negative, it opens downward, meaning that the arrows are going down. Zero of a function is an x value that makes a quadratic function equal to 0. That's why we call them zeros, because whenever I plug them in to my function, I get 0. A quadratic function may have 1 0, meaning that it crosses the x-axis in one place, like this one. It can have 2 zeros, meaning that it crosses the x-axis in 2 places, like this one. Or it can also have no zeros, meaning that no matter what, it's never ever going to cross this x-axis like this one, because this one's going to keep going up, so it's never actually going to cross the x-axis. So you can have no zeros, 1 0, or 2 zeros. These are also known as the X-Intercepts of a function, because again, it's where it's crossing the x-axis. Alright, we're going to look at your note sheet and pick out some of these zeros here. So right now I'm looking at number 1, and number 1 is y equals x squared minus 2x minus 3. And here's my graph, or my parabola. Okay, and we're wanting to pick out the zeros, and the zeros are where does it cross the x-axis. So it's going to cross right here at -1, and right here at 1, 2, and positive 3. So for our zeros, we're going to do our braces or our squigglies, because it's a set of answers. It's not a point, it's a set of answers. And our answers are -1, because it crosses the x-axis right here at -1, and it crosses right here at 3, so -1, 3. And our other set of braces are squigglies. Okay. Now we want to check this, because again, it's called zeros because when I plug in -1 for x, I should get out 0, and when I plug in 3 for x, I should get 0. So let's see if that actually happens. Alright, so it's y equals x squared minus 2x minus 3. So again, it's a 0, so it should equal 0, so my y is 0. And then everywhere I see an x here and here, I'm going to plug in a -1 first. So anytime I plug in numbers, I have parentheses, so -1 squared minus 2 times -1 minus 3. And I'm fine with you putting all this into your calculator. And if you do it by hand, -1 squared is 1. -2 times -1 is positive 2 minus 3. And if I say 1 plus 2 minus 3, I get 0. So 0 equals 0, and that checks out. Now we're going to check our other one. In other words, and everywhere we see x, we're going to plug in a 3, and that should also give me 0. So again, I'm going to put in 3 squared minus 2 times 3 minus 3. Again, notice that everywhere I plugged in a 3, I put parentheses around it, because anytime you plug in a number, it needs to have parentheses. Again, you can plug all of this part in your calculator if you would like, and it should give you 0. So 0 equals 0, and that checks out. So there's number 1. Make sure you have all that written down. Alright, now we're going to look at number 2, and again we're looking for the zeros, or where it crosses the x-axis, or the x-intercepts, and right here it crosses right here, and it only crosses in one place. So that's going to be -1, -2, -3, -4. So my zeros, again I need my squigglies or my braces. Now I'm only going to have one number this time, and it's going to be -4. So -4 is my 0. And again, it's called a 0 because when I plug it in, I should get 0. So that's what we're going to do. We're going to check it. Instead of y, we're going to put 0. And everywhere we see an x, we're going to plug in a -4. So I'm going to say negative 4 squared plus 8 times negative 4 plus 16. Again, notice everywhere I plugged in a negative 4, I put parentheses around it. You have to do that, especially if you're going to plug it into the calculator. That's going to give me negative 4 squared is 16. 8 times negative 4 is going to give me negative 32, or minus 32. Bring down my other plus 16. 16 minus 32 plus 16 gives me 0. So 0 equals 0, and that works out. Make sure you have down number 2 before you move on. Okay, and finally we're going to look at number 3. And if I look at the x-axis here, that U shape doesn't ever actually cross the x-axis here, and it's going to keep going downward, so it's never ever going to cross that x-axis. So for zeros, you're going to write none, because there is no zeros, because it doesn't ever cross the x-axis. And again, with this one, you guys like this one because if there's no zeros or nowhere where it crosses the x-axis, there's nothing to check here. So we're going to go ahead and move on to number 4. Make sure you have everything for 1, 2, and 3 written before we move on. Alright, we've looked at the zeros. Now we're going to look at the axis of symmetry. A vertical line that divides a parabola into 2 symmetrical halves is the axis of symmetry. The axis of symmetry always passes through the vertex of the parabola, and here's just a couple of examples of where we see U-shapes in real life, okay, or parabolas. All right, and we can see on both of these pictures. Again, it's going to be that line that cuts it into 2 symmetrical halves, meaning that I could cut it right here and fold it, and it would be the same on both sides.
Alright, so we're going to look at number 4 on your worksheet, your note sheet. Sometimes the axis of symmetry is going to be like it is on number 4, where it's going to be really easy to spot and we're able to just eyeball it and we don't have to do much work to figure it out. If you look here on number 4, you can see that if I draw a line right here, this is obviously the point where it's crossing, so it's going to be negative 1. So my axis of symmetry is, we're going to write it as x equals negative 1. So x equals negative 1. So that's an easy one. Now on number 5, if you'll notice here, it looks like it's about at 1, 2, 2.5. But there is a way for us to make sure that we have it exactly right. So what we're going to do is we're going to look at our zeros. And our zeros here are 1 and 1, 2, 3, 4. So we're going to say our zeros are 1 and 4. And we're going to add those. And then we're going to divide it by 2. So we're going to take the average. So when I divide that, add those up, I get 5 over 2. And divide it, it gives me 2.5. And that is going to be my axis of symmetry. It's x equals 2.5. So like I said, it's right about halfway. It looked like it was right at halfway, and it is halfway. Between 2 and 3 there. But that's how you are able to make sure. Number 6. We could do it the same way. We can take the average. But we can also look at our graph here and see that it's 1. And just to confirm, we'll look negative 1, negative 2, and then 1, 2, 3, 4. And we're going to take that, and the average of that, negative 2 plus 4 is going to give us 2 over 2 equals 1. So the axis of symmetry is x equals 1. And if I look where I drew my line, it is at the 1 on the x. So now here, number 7, again, we don't have to take the average here because we can see it's negative 1, 2, 3. So x equals negative 3 here. And just make sure that your axis of symmetry is not negative 3. It's x equals negative 3. You have to write x equals. And if you do not write x equals on your tests, as we go forward, then that's not a sufficient answer and it will not be correct. So on your homework and your test, just make sure your axis of symmetry is always going to be x equals that number.
And it's x equals because it's the line that cuts it in half. It's the actual line, so it has to have the x equals with it.
All right, so the next thing we're going to look at is the highest or lowest point on a parabola is the vertex. If a parabola opens upward, the vertex is its lowest point or minimum, and if a parabola opens downward, the vertex is the highest point or maximum. So you can see here, this is our axis of symmetry line that we just did and talked about, and then this orange dot here is the vertex, and this is a maximum because the parabola is opening downward. Again, a positive value means it opens upward. That A, the number in front of the X being positive, means that it's opening upward. And a negative number in front of the X means that it's opening downward. And if it opens downward, the vertex is a maximum. If it opens upward, the vertex is a minimum. And we're going to talk about that some more. So we're going to look at number 8. And we're looking at the point, the minimum point here on the parabola, and we're just going to name this point. This point is 1, 2, 3, negative 3 on the x and 1, 2 on the y. So that means that our vertex is negative 3, 2. And again, because it's the minimum, it goes down, down, down to this point and then goes back up again. It is, we write minimum or min. Okay? Now, number 9. Here is our point. We're going to count 1, 2 on the x and 1, 2, 3, 4, 5 on the y. So it's 2, 5. And that's our vertex, 2, 5. And because it goes up, up, up to this point, this is the maximum height, and then it goes down, down, down. It is the maximum. Okay? Here, we're going to name this point. We go 1, 2, back on the x, so negative 2, and 1, 2, 3, 4, 5 on the y. So negative 2, 5 is going to be our vertex. Negative 2, 5. And because it goes up, 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 this is the maximum point here, and then it goes down again. It is maximum. And our last one, number 11, we're going to name this point here. We're going to count over 1, 2, 3 on the x, and down 1, so negative 1 on the y. So that's 3, negative 1. And because it goes down, 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 this is the minimum. Make sure that you have all that down. You can pause the video if you need to.
Alright, now we're going to look at our domain and our range. Our domain are our x values and our range are our y values. The domain for a parabola or a quadratic is all real numbers. That's for all quadratic functions. Because no matter where I go left or right, if I go up far enough, I'm going to hit it. Or if I go down, if it's opening downward, if I go down far enough, I'm going to hit it. Now the range is a little bit of a different story. For this function, it's y is greater than or equal to 0. Because if I look down here, no part of that U shape is coming down here. So it's everything from right here at the 0 and up. So it's greater than or equal to 0. If we're looking at this one down here, and again, you don't have to write this down. The domain, again, is all real numbers because, again, no matter how far I go left or right here, if I go down far enough, I'm going to hit that U shape. So there's no x value that it's not going to be. However, the range, if I go up here, then there's nowhere that this U shape is going to go up here. So it's everything from here at the 0 point and down. So it's y is less than or equal to 0 for this function. Okay, we're going to look at our last set of problems here. So we're going to look at this quadratic right here, this parabola, and we're going to state the domain and range. My domain, again, for all quadratics that we're going to look at are all real numbers. And I'm going to just shorten that to ARN for all real numbers. Or you can write out all real numbers if you really want to. My range is the tricky part here. it's going to be y such that, all my ranges are going to start with the y such that, and here it's going down, so there's nowhere up here for this quadratic to be, so it's everything from this point right here and down. So it's going to be y is less than, because it's down, or equal to, and it's everything less than or equal to this point. And on my y-axis, or the y value of this point, is -3. So it's going to be less than or equal to -3, so, because it's everything from -3 and down. Alright, let's look at number 13. For number 13, again, my domain is all real numbers. So all real numbers. And then my range is going to be everything from this lowest point and up. So again, it's going to be y such that, because all my ranges start with y such that. And since it's going up, it's going to be y is greater than or equal to. And it's everything from this lowest point and up, and this lowest point on my y is at -1, -2, -3, -4. So it's everything greater than or equal to -4. Alright, finally, number 14. My domain here again is all real numbers. Again, you can put ARN if you want to. I went ahead and wrote all real numbers for this one so that you remember what that stands for. My range here is y such that y. And then if I look at my parabola here, it's everything from this top point and down. So it's less than or equal to. And it's everything everywhere from this top point and down. And this top point, the y value of this top point is at 3. 1, 2, 3. So it's going to be y is less than or equal to 3. And again, you need your braces for that. Make sure you have everything written for 12, 13, and 14. Before you move on, if you need to pause the video now, do that. Alright, so there are all of our objectives. We should now be able to identify zeros, the axis of symmetry, the vertex, and the domain and range of a quadratic. Alright guys, we want you to go ahead and write down your homework assignment in the yellow at the top. You can write it down on notes or a clean sheet of paper that you'll use tomorrow. We don't want you to actually start on the assignment, but we do want you to go ahead and have it written down and ready to go for tomorrow. So go ahead and take a minute if you need to, pause the video and write down the assignment. It's page 614, 16 through 21, 33 through 36, and page 623, 3 through 5, 19 through 24, and 41. When you have that done, that is the end of your video. Thank you for watching.